Hello and welcome to the class. Today's topic is trigonometry, and today we'll discuss about the part 1, mainly consists of the Pythagoras Theorem, trigonometric ratios, then how we can find the angles and all. So consider this is a right angle triangle and opposite to 90 degrees hypotenuse. So this is hypotenuse B, and adjacent is, this is opposite to angle is always known as opposite, and adjacent to the angle is adjacent. So this is right angle triangle. AB is the adjacent of the base, BC is perpendicular, AC is the hypotenuse. So what is Pythagoras theorem? In a right angle triangle, the square of hypotenuse is equals to the square of sum of the square of other two sides. That means B square is equals to A square plus C square. Now how we can write the trigonometric ratios? So if this is a right angle triangle, then if I wanted to write about the sine A, so sine A is always opposite upon hypotenuse. So in this case, opposite to angle is opposite, so that's why A upon, this is A upon B. Similarly for cosine, it is C upon, that means adjacent upon hypotenuse. Tangent is opposite upon adjacent, which is A upon C. Cosec is 1 upon sine A. And in this case it is like hypotenuse upon opposite, which is B upon A. Sec is reciprocal of cos, so it is hypotenuse upon adjacent, which is B upon C. And cot is 1 upon tan A, which is reciprocal of tan, so or we can write cos upon sine. Like tangent, tan of A is sine upon cos, this is sine upon cos. Similarly, cot A is cos upon sine, and in this case it is C upon A. So trigonometric identities. So there are three trigonometric identities, which is sin square theta plus cos square theta is equals to 1, or we can write sin square A plus cos square A is equals to 1. 1 plus tan square A is equals to sec square A, and 1 plus cot square A is equals to cosec square A. So these we are going to use. Now consider this is one question, first question, and the triangle ABC, right angle at B. So this is triangle ABC, right angle at B. I can, okay. Now AB is this, sorry, this is C. So AB is given, AB is almost 24 and BC is 7. Determine sine of A, that means this angle. So how we're going to find? So first of all, using Pythagoras theorem, 90 to opposite, this is hypotenuse. The square of hypotenuse is equals to sum of the square of other two sides. So we can write here AC square is equals to AB square plus BC square. In this case it is 24 square plus 7 square. 24 square is 576 plus 49, which is equals to 625. So AC is equals to root under 625, which is equals to 25 centimeter. So now we have all the things in the triangle. Now what we can do, how we can find sine A. So sine theta is always opposite upon hypotenuse. So opposite upon hypotenuse, what is opposite to angle A is 7 upon hypotenuse is 25. So 7 upon 25. If cos A, cos is adjacent upon hypotenuse. So adjacent in this case is 24 upon 25. Now if they change the angle, now angle is this angle. So in this case, if I wanted to write sin C, it is always opposite upon hypotenuse, but opposite in this case is AB. So we'll write here AB upon AC and 24 upon 25. Similarly, cos C, so again cos C, so adjacent in this case, adjacent is BC and hypotenuse is AC. So we can write here BC is 7 upon 25. So one thing you need to remember, this is shortcut, so ka to ha. So sine is opposite upon hypotenuse, cos is adjacent upon hypotenuse, and tan is opposite upon adjacent. Okay, now moving to the next question. In triangle PQR, right angle at Q. So in triangle PQR, right angle at Q, So this is, consider this is PQR where right angle at Q. Consider this is P and this is R. Now PQ is given, which is 5 cm. PR plus QR is 25. Now this is 25. So what I am going to do, I'm just going to take, this is X. So this will be 25 minus X. Why? Because the sum of these two is equals to 25. Okay. And then determine the value of sine P, cos P and tan P. So we need to find out the value of X. So how we can do using Pythagoras theorem, square of hypotenuse. So in this case hypotenuse is PR. So this is equals to 5 square minus 25 minus X whole square. Now X square is equals to 5 square is 25. Now we can use the formula of A minus B whole square, which is A square minus 2AB plus B square. So we can write here 25 whole square minus 2 into 25 into X plus X square. Now we can cancel this X and X square. So we can write here 0 is equals to 25 plus 625 minus 50 is equals to X. We can shift this 50 over here. 50X is equals to 650. Can we cancel this? X is equals to 65 upon 5, which is 13. Now we have X. So we can write here X is 13 and this is what, 12. 25 minus 13 is 12. So determine the value of sine P. So sine P, so is SOH, opposite upon hypotenuse. In this case opposite is this. So we can write here QR upon PR. So it's now easy. QR is 12 upon PR is 13. So it is 12 upon 13. Similarly, cos P. So cos P is equals to what we can write here, cos P, again this angle, adjacent. So adjacent because CH, adjacent upon hypotenuse. So PQ upon PR. So PQ in this case we can write here 5 upon PR is 13. Okay, now tan P. So tan is like, so TOA. TOA is TOA, opposite upon adjacent. Opposite is QR upon adjacent is PQ. So we can write here opposite is 12, 12 upon 5. So this is how we can solve question. So if this is given, like if 15 cot A is equals to 8, find sin A and sec A. So cot A is equals to how much we can write here, 8 upon 15. Now cot is what, reciprocal of tan, and tan we know, TOA. So TOA, opposite upon adjacent. So in this case we can write here adjacent upon opposite, right? So what is missing here? Hypotenuse. So we know square of hypotenuse is equals to sum of the square of other two sides. So 8 square is equals to, this is what, 15 square plus 8 square. So h is equals to root under 15 is what, 225, and 8 is 64. We can add it, 289. So h is equals to 13. So now we have, sorry, not 13, 17. So now we have this 17 into 17 is 289. Now sin A. So sin A is again so SOH, opposite upon. So we will write here opposite upon hypotenuse. So opposite is how much in this case? If you see, opposite is 15 and hypotenuse is 17. Similarly, CK is 1 upon cos A, or we can write here 1 upon adjacent upon hypotenuse, or we can write hypotenuse upon adjacent. So how much hypotenuse? So hypotenuse is 17 and adjacent in this case if you see 8. So our answer is this. In a right angle triangle, right angle at B, tan A is equals to 1 upon root 3. Sorry, I missed this root, so that's why I wrote it down. Find the value of this and this. And what is the value of this? So in a right angle triangle like this, right angle at B, tan A, that means if I consider this angle, so tan A is equals to 1 upon root 3. So we know tan is what, 2 opposite, and this is adjacent. So if this is opposite, this is adjacent, what is missing? Hypotenuse. So AC square is equals to, can we write like 1 square plus root 3 square? So 1 plus 3. So AC is equals to root under 4, which is equals to 2. So now we have this. If I considering like tan A, so opposite is 1 and adjacent is root 3. Now what they are asking us to find out? Sin A into cos C plus cos A into sin C. So sin A, we know if this is sin A, so the opposite of this one is this. So we will write here BC upon AC. Now cos C, if I am going to consider this one, so adjacent will be BC. So I will write here BC upon hypotenuse is what? AC plus cos A. Now the cos A, so this will be adjacent. So adjacent is AB upon hypotenuse is what? AC into sin C. So again this is sin C, so opposite of this one is opposite. So we can write here AB upon AC. So can we write like BC square upon AC square plus AB square upon AC square, or since these two are same, so we can write here BC square plus AB square upon AC square. And BC, how much BC in this case? BC square plus AB square, we can see using Pythagoras theorem, we can write here AC square. So directly we can write here AC square upon AC square, cancel out, and we can write here 1. If you are not comfortable with this, you can just substitute the value which we already calculated. You will get definitely answer 1. So part 2 I am giving you. You can give it a try. In case of any doubt, you can put your comment in the comment section. Thank you for watching this. I will make next video for the trigonometry part 2.